So, hello and welcome to our Dlubal podcast, today in English. So, the first one, the first episode in English. I hope it's okay. Maybe it's also very interesting for those who are abroad from Germany, so also English listeners. So, it will be a very nice episode today. Today about a very interesting topic in the construction industry. The way we plan buildings and structures is moving forward, is changing. And also the way we plan these structures is also changing. So especially the thing parametric design. So set up different parameters in order to create and to plan new structures will be more and more important. And therefore, we have a very nice guest today. I say welcome and hello to Junghwo.
Hi, thanks for inviting me.
You're welcome. Junghwo, who are you and what are you doing?
My name is Jungwho Park from South Korea. I'm an architect, educated in Korea and Australia, and also in Vienna, Austria. My role in Austria, I'm working the company called Group Ventures. So it's a group of research and development group within Group. And my domain is BIM specialist and project engineer, dealing with different software development for our Asia industry. And I'm also consulting some our external clients for the BIM topic.
Yeah, thank you for your short introduction. We would like to ask you more questions about your job and your study. So first of all, why did you choose to study this topic, and what is so fascinating for you about this?
Yeah. So as a Korean citizen, I didn't know what to do when I was young. So I went to the army for 2 years, and then I decided to travel to Australia, just, going to farm and picking up some cherries and traveling and going to traveling around 1 year. And luckily I met one painter who painted building for like last 25 years in Melbourne, Australia. And I was following him, and I also into painting. So I start to paint building facade or elevation with him. And he just suggests, oh, Park, that back then people call me Park. So he called me Park. His name is Salvatore, Italian guy. I think you are very talented in drawing and especially building. You have good observations and etc. So I decided to take the exam in Melbourne, RMIT University for architecture school. That's how I enter at the beginning architecture school, and then I've practiced in Australia as an architectural assistant, draftman, and step by step or basic procedure. And I decide, okay, for me, if I'm doing, it's great, generic building to design, but I was very fascinated by something extraordinary. So I decide to travel to Germany for 1 year to see from Germany's center. It's easy to travel along the different frontier. And I figured it out, okay, maybe it's good time for me to study master degree in Europe. So I was searching for like well-known star architects who teach at university, and I found out my former professor, Zaha Hadid. She is teaching in university, the Applied Arts, University of Applied Arts in Vienna for last 15 years. So I was like, okay, this sounds good. So I applied there, and that's I start to learn about parametric design or generative design, computational design, all these different words. So that's how I started.
And that's why you are still in Vienna now?
That's right. So after graduate, somehow, yeah, I just staying in Vienna. It's a nice city.
Ah.
You said Zaha Hadid?
Yeah.
it's one of the most famous, or I think the most famous architect in the world. Also, of the
She was very well known star architect and one of the first women who got Pritzker's prize. This is like architecture award. She as a woman she got first prize, and I always admire her architectural language. And also the Professor Patrick Schumer was also teaching together with Zaha Hadid. He's partner of Zaha Hadid. At the moment, he's principal of the Zaha Hadid Architect. And yeah, it was really great chance to learn this parametric design in university.
I saw some projects of Zaha Hadid, and the buildings are very special because they are free-form buildings. So very hard to describe it in a form, in a shape. Maybe give us a short review about the architecture.
We at university as a master study, we research a lot about actually not only form finding from Zaha Hadid class, but we explore all kinds of design technologies using parametric design solution. And for the first 1 year, we've focused on structural analysis using software called Caramba 3D. We researched all together. We had about 23 colleagues together in master degree study. And we exploring all this sort of new technology using Grasshopper and Caramba 3D to analyze conceptual stage of building from all kinds of prototypes. And then that research was 1 year, brings us a lot of chance to learn about structural engineering. And we realized that structural engineering is really close to everything is about parameters, material parameter properties, like road cases, everything is dealing with parameters. So it was good practice to combine architectural concept for structural design, and that class was specifically called tectonic architecture. So we actually learn a lot in this different world. And of course, the whole Caramba developers, Caramba 3D developers, they visited university and they had a short intensive workshop at the beginning. So we, like all the students was fully engaged with this new technology in terms of structural analysis.
Cool stuff.
Yeah, sorry, I forgot your question. So Zaha Hadid style, I cannot really define the style, but I guess she didn't really teach us, of course, but she was inspiring us. So I think
she shared their visions, I think, in order to teach you what is everything possible.
Yeah. She used to say, I cannot teach you, I can only inspire you. So I guess we just get a lot of inspiration from her, like, because inspiration is difficult to teach anyway. And imagination is also difficult to teach. And her building style is A to Z, everything is different. So difficult to define what exact style is. Right.
Yeah, cool. It's very interesting. And I know you told us before about your job, but maybe to introduce in our big topic today, you can tell again what exactly you are doing in your work. And yes, maybe you can tell us something about this.
Sure. So the Umdash Group Ventures, we working together with software developers and also hardware engineers, who is inventing the sensors, and we have also marketing team, and I'm myself BIM specialist, and we have also virtual design construction manager in the organization. What we do, we have a couple of prototypes. First of all, one product called Contact, which we can install the sensor on formal installation. So the sensors measuring the mass quantity of the poured concrete and the drying time and temperatures and all this sort of on-site field condition of data that is automatically synchronized to the server. And in the server, we have the BIM model, the concrete BIM model that receiving the data from the sensor. And also the construction manager, they can plan when this formwork need to be installed and which part going to be constructed and when. So based on this cycle plan, the builders are working on the construction stages on site. This is one of the product, and another one called NeoTwin. It's another department. We are developing a software called Prometric. It's a little bit difficult to pronounce it, but Prometric. We concentrate on real estate management and also from building owner side or developer side, property developer side. We are consulting how to manage the project in efficient way using digital technology. So there is a BIM model we can integrate in this specific application, and there all the cost management, planning management, and phase. Yeah, so all tendering process is integrated in this one application package. So we are developing this agile, and I'm currently also working on retail sector to come up with some BIM building information design solution for the retail area. Or we have also Neorant, which is another department trying to provide affordable housing in different continent like Africa or so we ship precast concrete factory to different continent, and they prefabricated this affordable housing on site in different continent, and they deliver affordable housing. So there are many things happening in our organization, but my main role is just supporting our team, front and end developers, and also somehow collaborate, because the developers need to know the direction also, and the client also needs some consulting service from our side. And as a BIM expert, I'm just support both internal and external team.
It sounds really so interesting.
Thank you.
And so we want to know more about parametric documentation and computational design now.
Mhm.
So maybe also for our listeners, first, can you tell us what we can understand by computational design in architecture?
Yeah. Okay. It's actually it's nothing different than CAD, CAM things, but I would say we using parameters and using the parameter value of the parameter as an information to manipulate or to come up with some architectural typology. And it's not only about form finding, concept design, but it's also you can use it for analysis purpose. For example, structural analysis is the really great example of using parametric solution, computational design solution, or like environmental analysis, like wind effect or solar radiations and all this kind of thing. We have to get the information and analyze and use this big data of information to design the better building. So the parametric design is really broad. It's not only about form finding or some sexy design for the curved building or something, but you can also use it like a more automation, for example, the prefabrication or digitalization of the construction stages. You can all use. So basically, everything we are doing, architects or structural engineers, infrastructure engineers, or even BIM managers, whoever involved in our industry these days, or even facility manager, they all play with the numbers, right? Numbers and information. And I think this is, I would define everything what we are doing is basically parametric I cannot say design, but documentation or management, information management, and parametric or computational design is directly dealing with this different variation of the field in our industry.
And can you maybe describe some examples and where the benefits and the advantages are in this?
Yeah. So traditionally, architects or structural engineers used to just sketch it, right, with a ruler, pen and ruler. So when you sketch something, and if you want to change the length of your sketch, you end up using tracing paper, butter paper, and then draw on top of it, or you start to remove with the eraser and draw it again. But it's once you draw the line, it's fixed. There is no variable we can change the this length of your sketch line, right? But the parametric design or computational method, we are using parameters as a variable, so we can change anytime we can make a different variation with parameters. So if we, let's say, for example, length is a very typical parameter. We have a column that start from 0 and up to 3 meter. We have element, and we can put another number and it grow 4 meter. So that allows us to, you know, work efficiently in a way. So I would say that's a great example of using parameter, but this is only single example. If many constraints, the parameter set of parameters react based on the environmental effect or the design agenda, then they will simultaneously change all this adjacent relationship. So this is somehow generative design or parametric design using this set of parameter that linked each other, I would say algorithm that we can review or always filter out for the later use.
Yeah, and what are the technical applications for that? So maybe Rhino or Grasshopper, or
okay.
What else can we use?
So in building industry, we use, of course, you can just use text editor without any software, like such as Python or C#. You can use Visual Studio or Visual Code, and you can come up with any text programming, you know, then you can make certainly parametric design approach. But in our building industry, we commonly use Rhino or Grasshopper by McNeil Associate, or Blender is also growing, and you can integrate with Python. It's open source, it's nice. And if you're looking at game engine, but we use a lot in these days in building industry called Unity 3D. We can use C# script to manipulate or parameterize the our tasks. So I think those are one of the major parametric design tool. And currently, many BIM authoring software such as Revit and or Allplan or ArchiCAD, you know, the Bentley products, they have their own parametric design solution. So there is also Dynamo Beam for Revit, Autodesk Revit, or ArchiCAD is directly linked to Grasshopper with Rhino. And currently also Rhino is inside of Revit, so you can use Rhino inside of Revit as a parametric design solution. Or you know, I also seen some of them using just typical AutoCAD, but they script the AutoCAD script text script, and they can also come up with a very interesting geometry. So I cannot constrain, I cannot define which software is specific parametric design tool, because I think these days everything is parametric design tool in the end. Like even or like a Sophistic or Dlubal, you all using parameters. So indeed everything is parametric design, or it's difficult to say parametric design, but computational design tool, you can use it then.
Yeah, applications which can be based on parameters in order to make it more convenient for the user. But do you think that these parameters restrict maybe also a little bit the creativity of the architects? Are there any restrictions which can influence maybe the creativity of the architects?
Yes, sure, because it's not easy to provide all kind of parameters like like temperature, wind speed, or everything for to do the schematic design. Is of course maybe difficult to do it, but you need enough practice and understand this is like you need strong practice to use this sort of parametric design tool, or you don't only concentrate on those constraints of parameters, but you can be you can, just like our hand sketch, you can also use this form finding strategy without too much constraints. So accidentally you can come up with some form as an architect, just like sketch. But it all depends on how you want to approach. But sometimes it can be very dangerous, because if you don't set the parameters correctly to deal with your design requirements, then whatever you do is completely wrong. So actually, that's the downside of using parameters to come up with a design, I would say.
So you were also talking between architects and engineers. It's very important to have a good communication in order to have a very good good foundation for the whole project. So how do you see the collaboration between architects and structural engineers at the moment?
I think that's key to succeed, to collaborate both two different disciplines. I worked for structural engineer or architecture firm where they already has structural engineers within the team. So it was very nice. If as an architect we can propose our concept, and then we can directly communicate with the engineer within the team. So you can see the response directly, like, okay, I was wrong, this is not possible, or maybe it's too costly, too dangerous. We can get the response directly. And also in terms of sharing the model, the common model together, makes us much efficient to approach the goal together. So I really think that the architect and structural engineer must work together, not only the later stage, but possibly from the beginning altogether. That brings us a lot of efficiency. So the structural engineer doesn't have to completely redo the work for their calculation, because from the beginning, the engineers can show us how we can set architectural model for them to use later phase in calculation, or I don't know, for the reinforcement detailing, or and etc. So working together is very important, I must say.
Yeah. And for now, we already had episodes where we talked about the problems of BIM and everything, but do you think BIM is still just a tool or a working planning method, or is it more?
It's really broad domain what BIM is. That also many people say nowadays building information management, not building information modeling. But BIM, indeed, the single source of truth is coming from model. The quality of model is very important. If model is wrong already as an input, then all the output, whatever the information we are leveraging from the model is wrong. So the model is very important. And people who dealing with building information modeling in facility management or sustainable design, anyhow, anyone who involved in this it's not new, it's this BIM world, and they always use the model. So the model is the essential source for all disciplines. So building information modeling, it's very tricky work. For me, it's nothing different than traditional CAD work, 3D model work, but we are now more strict, and we providing much more information within the geometry. So non-graphical information is in geometry. So our task became much more strict, but at the same time efficient, I would say, becomes efficient with the BIM.
Yeah, but why do you think that so many architectures and also engineering offices still don't plan with BIM?
The main issue is the BIM cost at the beginning. You need to train the employees, regular training, not just the one-time training and finish. It's not possible because you have to set for company contents, library, like templates, and certainly whatever BIM tool we're using, it's digitalization. It's no longer just hand sketch. So someone need to know exactly like a big, deep technological part to implement the company use. And every company has different style, right? For example, in architectural office, you don't draw piece of tree in your building drawing. Nobody drawing exactly same human figures or the trees. Everybody has different style, even text font. So there must be someone who providing them the exact style that they can use even in this current digitalization world, because traditionally some architects wants to have exactly their sketch for their drawing, right? But this is very difficult to do it in these days, and someone need to spend a lot of effort very early stage. And I think the benefit you can only find out with the time, like at least whole project, their pilot project is being done, and you can see there was difficulties and there are benefits. And then with the time, they can see more benefit in the future. But our industry is everything. The big enemy is the time, and also the small budget of architectural service or structural engineering service, I would say, in comparison to product owners or manufacturers. They earn, I think, much more revenue than planning team. So I think that's the main difficulties. The small companies or the big company who wanted to implement, then the main first source they need is a human resource, not just software. The human, the team, the building of team, it's cost a lot, and it's a big challenge for the company. I think that's why with the time, you have always these time constraints and difficult to spend their own investment. I think this is the major issue, but it's being better and better.
And because I think it becomes better and better because also the education, especially from the universities and colleges, are focusing more on educate the students concerning building information modeling and also digital planning of structures. And when they have already some experiences and also the experience with the software, and they come to new engineering or architecture offices, they can teach the other ones what they have learned, and also try to do this maybe for the first time at the pilot project or something like that, in order to gain new knowledge about planning with BIM. And when I did my research on my master thesis, I also discovered some other issues, and these are, for example, the standards. So that you don't have any unified guidelines. Everybody is planning with other libraries, with other software.
Mm.
There's no basic, so which everybody would connect to everything, yeah, and to unify everything. This is also one of the biggest challenges in the whole BIM process when you are doing it the first time.
Yeah, and the standardization is also time consuming, and you cannot just standardize only your company standard. You have to match to external parties or the governmental national norms and national standards. So there need a lot of effort to set these assets for your company. That's why it is the challenge, really, indeed. But again, the most difficulty is building up the right team, and the human resource is the most difficulties in reality, because software you can buy if you have project, right? And you can train people, but if you don't have right people to be trained, and then already it's wrong at the first place. So the human resource, I would say, is most important. So to say, it's mindset. The whole mindset of the company is more important.
And in my opinion, also the whole construction industry suffers also a little bit from the lack of employees who has experience with that. Yeah, and in general, the whole construction industry, there's a lack of, in my opinion, qualified and well experienced employees and engineers and architects.
That's right.
So our podcast is a little bit about digitalization, the future of construction industry. So it would be very interesting. How do you see the future of the construction industry, planning buildings? What do you think?
Actually, I also personally did many interviews with other people, and I realized that future wouldn't be not much, like more or less same, I guess, because the idea of this digitalization is being already implemented since 1960s, 70s, right? With or like not in building industry, but in industrial sections like automobile industry or manufacturing industry, they all like digitalized it already since 1970s. And building industry, we start to realize our own problem, but it's different than just producing the product. Every building, every land, every earth on environment is different. So that's why it's difficult to somehow digitalize every single building or infrastructure project. But my understand right now of this digitalization, it's getting better. Really, I see a lot of effort from everybody involved in our industry. So I see the future going to be much bright for sure than now. Already in present time, I see there are a lot of improvement in globally, not only in Europe, but in Asia, in America, North America, South America. Everybody is supporting this new technology. So I think future will be much more efficient in our industry, as close to, hopefully, to the manufacturing industry. But at the same time, nothing different. So we'll do similar job, but there will be much developed standardization and the regulation from the government, the governmental level or international organization level. So I think in the future, it's much easier for us to follow that rules or protocol from the national level, I would say.
Maybe let's take also take a look to the planning companies. So do you believe, are there any changes in the culture of architecture and engineering offices? Because in Germany, for example, we have a lot of free and independent planners, whereas in England or America, they are really huge and big planning companies, general planner.
Yeah, I think it's as you said, from the education, young generation, new graduates, they are very familiar with all these digital tools. Most of case, now most of architects or structural engineer students, they're using 3D model, not just hand sketch. So for sure, it's much better. Like regardless of small office or big office, I think it's getting better and better. But the funny thing in architects, I don't know exactly in structural engineering office, but architectural office, the funny thing is that it doesn't guarantee the architect is very good if you use this digital tool. There are still in architectural planning office people traditionally working, but the end result could be even better. You know, it's very controversial. I don't know how to explain exactly, but not every like good architects are super efficient in working in digital world, but they still produce a lot of good job because they are more. There are a lot architecture. It's not only about technology. It's a lot to engage with culture and like artistic point of view, and also the architect the way of thinking to trying to solve the the human scientific values in building. So not everything you can digitalize it, but nevertheless, I think the yeah, small office or big office these days, they are all trying to follow this new technologies. So I think there will be a big improvement. Yeah. Maybe in 5 years later, nobody gonna talk about this anymore because everybody is doing it. So
I see also their trend, and maybe this is also a good question for you, that a lot of engineering and architecture offices build up their own department or development department team for programming such computational or parametric planning tools, design tools. So would you agree when I would say, okay, every engineer and every architect has to learn programming in the study, or has to learn it?
Absolutely. I not only for engineer or architects, I think any domain, regardless of building industry, scientist, or I don't know, the accountant, anyone who working in the future, all need to do the programming, I think, because that way you can be more creative, you can be more efficient, and you not get bored, of course. You can customize. So yeah, especially for architecture office or engineering office, I would say every 15 or 20 employee, at least there need to be one programmer who could maximize or support them to be more creative or customizable, scalable, like production in their plannings. Yeah.
So to our listeners and to those who are studying right now, learn programming because you will need that. And I think this is a good tool when you have experiences in programming and you can help the company maybe in developing such tools for something like that.
Sure. Myself, I'm also learning programming. There are so many, it's a big word again, the developers, like a software developer or programmers. There are so many languages, JavaScript, Java, or, Python, C#, C++, all the F#. There are so many variations these days. But I guess everything is based on logic. So learning programming is you never get bored. So you can organize your thought in more structured way, let's say. So eventually it will help everybody to be efficient when you start to learn programming. I think I'm not in good position to say this kind of thing because myself, I'm not programmer, I'm architect, but certainly this computational thinking or programming to learn in the future would be definitely beneficial for everybody, everybody in the world.
Yeah, to get an understanding for that and also to a feeling.
Yeah.
And what do you think about other main technologies and trends like 3D printing or modular buildings?
This, I think it's a very optimistic with the development of the technology, especially for 3D printing. I don't see much benefit in small scale, let's say. In my opinion, personally, I would say 3D printing technology could be more beneficial for big, large scale of military infrastructure or some very customized, difficult to build, like delicate bridge design that you can print or weld it with steel, you know, or I don't know, some big span that difficult to approach with a traditional formwork, you know, because formwork also it need a lot of planning to do the formwork design. But with a 3D printing, if you 3D print it, then you know, the amount of effort to produce formwork equipment is also reduced, and the material optimization, you know, we can save up a lot of materials doing that. I know it's not easy because you don't have support conditions. So when you print in certain, when it goes further, some point you have to think about this construction stage, you know, the all different roads, so it may collapse. But I think a lot of researchers and developers these days, they are aware of this problem, and they specifically investing on these difficulties. So I think 3D printing, digital fabrication is the future. You can be efficient. You can build your house in 2 days. It depends on material. Material and scale is big tema. If it's only timber construction, I think small scale is also very good with the digital fabrication because you already built everything from the off-site, and you just need to assemble on-site for small-scale project. But I see this new technology definitely much beneficial for big project in the future. Spaceship, or maybe our building, it will be float without any foundation, so you don't have to worry about earthquake. And maybe to do that, to approach this kind of new building prototype, you need new technology for sure, I think.
One action less to consider. Maybe also in one point to how fast is the construction industry in the whole digitalization process? Because I think everybody knows, okay, we are still slow, or are we still behind our expectations?
Very slow, of course. We are compared to, if you think about aerospace engineers, right? We flew to the moon or space already in 1960s. So in comparison to that, or automobile industry, in 1970s, especially in Germany, they digitalized all kind of manufacturing technology. They did it within very short amount of time, or you know, the manufacturing technology. And with the electronic car these days, everything developed last 5 to 10 years. Every, you know, the new technology already came out as a product. So in comparison to that, our industry is super slow, super slow. But I guess everybody is recognized, especially governmental officers or governors, they who are in charge of construction domain, they recognize the problem of our industry. So they trying to push the regulation from the governmental level. So we have to follow this digitalization, definitely. I don't know how long it will take. The thing is, we cannot force people to do it. These days, but without digitalization, you lose your potential clients as an architect or as a structural engineer or MEP engineer. So for us, digitalization is definitely, we need to speed up.
That's true.
Yeah. So Daniel, do you have other questions?
No, I think.
Yeah. So then it was really very, very interesting. And before we have to end this, we always ask our guests which building is your favorite one. So can you tell us about your favorite building?
Favorite building. It's I have different scale of favorite buildings, but I would say who I admire as an architect. I like Glenn Market. He's an Australian architect, very cultural respect, only practice within Australia. He never practiced outside of Australia, but he taught many different universities around the world. And I really admire him because he inventing the details that needs for within the cultural aspect in Australia. So I really admire him as an architect. And also, sorry, I have one more architect really admire. It's called Enrique Miralles, Spanish architect. Unfortunately, he passed away in a very early age and kind of forgotten architect these days, but it's one of the genius, I would say. It's like I like the building which respect their environment and culture. So I like the term called critical regionalism architecture. It's not traditional building, but it's not a traditional kind of approach. We use any kind of modern technology and postmodern like kind of prototypes, but it respects environment and culture specifically for architectural design. I really like that.
Yeah, cool. I wanted to ask before if you have ever met Glenn.
Glenn Market.
Glenn Market. Yeah, I just met him only once in Australia, Melbourne. I was involved in competition as a student, and I was finalist. And in the award, he was there, and he provided all the awards. And so I just handshake, but didn't talk much in person.
Okay.
I was first year student, but I just realized and I found him, and I really liked. Of course, my professor. I had three different former professors. They Peter Corrigan in Australia, Zaha Hadid, and I actually graduated with Kazuo Sejima, if you know the Japanese architect. So these three architects, I also definitely admire them. I love their buildings. I cannot really say which building is my favorite building, but I really...
Yeah. No, but I can understand this. So thank you for your time and that we could speak with you. It was really, really interesting. And yes, I think our first English episode is not so bad. And thank you that you were our guest in this episode.
Thank you very much for your flexible and tolerant idea to have interview in English. I really appreciate for the invitation.
Can you speak German?
Little bit.
Okay. Yeah, good. Then.
Okay, Jungwho, thank you very much for your time. It was very interesting. And I hope we stay in contact. Thank you.
Yeah.
Thank you.
Good.
Bye-bye.
Bye.
Bye.